Exercise 9 in booklet 1 here, we get to know the following of the four functions p, q, r, and s. And let's start with the first point here. P derivative of 0 is 0, and p derivative of -1 is less than 0, which means that this is negative, right? So this is negative. And there's a lot of information here, and we want to find the graph which fits each of these functions. Let's start with p. And the derivative when x is 0. So when x is 0, that's here, right? Here x is 0. In all functions, of course. And then the derivative should be 0. So this means that when x is 0, we know that if the derivative is 0, it's either a maximum point, a minimum point, or a terrace point, like this. And we see that this is true for a. Here we have a minimum point. It is also true for D here. So it can be A or D according to the first information here. But then it says when x is -1, the derivative is negative, which means that the function should decrease, go downwards when x is -1. And when x is -1, here we see that the graph is decreasing. So this fits this information, and D was the other opportunity, but when x is -1 here, we see that the graph is increasing, right? So this means that it has to be graph A. So this is P. Then we should find out which graph Q is, and here we see the derivative when x is 1, the derivative is -2. When x is 1, the derivative -2, which means it has to decrease when x is equals to 1. So let's look at B here. We see that graph number B is increasing, so it's not B. When x is 1 here, it's also increasing, so it's not C, so it's either E or F. And we see that when x is 1, we see that the graph is decreasing, so that's good. But here when x is 1 is also decreasing, so it's either E or F according to this information. But here we see that when x is 2, the graph is decreasing also here. So when x is 2, it's also decreasing. And this fits both of them. When x is 2 here is decreasing, but when x is 2 here is also decreasing. But we see that the rate of change is -2 in each point, so it should be decreasing at the same rate of change in both these points. And that's exactly what we got here, right? When x is 1 and when x is 2, we see that the graph is decreasing with exactly the same rate of change compared to this, where there is this decreasing not too much, but here is decreasing more than here. So we cannot get the same answer. But here it's the same answer, so this is E. E is Q. Q is E. And then let's go to the function R. We know that in the interval between -2 and 0, that's when the interval from x equals to -2 till x equals to 0. In this interval, the average rate of change should be equal to 3. Let's look at number B here. We start at x -2, then it's 0 degrees, and when x is 0, it's still 0 degrees, so there's no change. The average rate of change is 0 here, right? So there's a lot of change, but the average rate of change is 0. So it's not this. Let's look at number C here. When x is -2, we have -4 degrees. When x is 0, we have -2 degrees. So, and remember the rate of change, the average rate of change, change here is, you can use this formula if you want. If you look at the formula booklet, you will see that there's this formula. And here we see that the change in y is 2. So it changes by 2 in the y direction. The temperature increases by 2 in 2 hours. So the average rate of change, if the temperature changes by 2 in 2 hours, the average rate of change is 1 per hour. So it's not 3. So it's not C. And then we have D here. When x is minus 2, we have here x is 0 is here. So the temperature is increasing by approximately 1 in 2 hours. So this is not this as well. But if we look at F here, when x is minus 2, there's minus 2 degrees. And when x is 0, it is 4 degrees. So the temperature changes by 6 degrees, increases by 6 degrees during 2 hours. So the change here is 6 degrees. It's not degrees, of course, but just to understand here, divided by 2 hours, and that is 3 degrees per hour. So forget about the degrees, but the average rate of change from here to here is 3. So this is R. And then the last one, S here. Now we don't have too much alternatives left, but it says that in this point when x is minus 2, the equation of the tangent line is this, and when x is 2, the equation of the tangent line is this. And this means that the tangent line, the most important thing there is the slope, the gradient, stigningstal. So this means that if the gradient has slope minus 8, this means that in this point the derivative is equals to minus 8. Right? The derivative gives us how fast it's increasing or decreasing in this point, and that's the slope of the gradient. The derivative is also called a gradient function. So let's look at B here, for example. We see that when x is minus 2, that's here, we see that the tangent line is pretty downwards. There's a lot of change, negative change here. So this could well be true that when x is minus 2, the gradient of the tangent line could well be minus 8. So this fits this information here. And if we see in the point x is 2, this is this point here, we see here also that the rate of change here is negative. This is annoying. Like this, right? And it seems to be the same slope here. So this may also well be true that the derivative when x is 2 could also be minus 8. So this looks really promising. And the other alternatives is C, where we see that when x is minus 2, it's increasing, so we can forget about this. Same here, it's increasing, so we can forget about this. So it's B that is correct, so this is R. So then we have P, R, Q, and sorry, this was not R, this was S. So there you go.